Yes.
Now, can you tell me what type of CNC machine tool you're going to be using? And
It's
what
3 axis.
processor you'll be needing? 3-axis. Do you
3 axis.
happen to know the name of the CNC machine or the
No.
controller?
No.
Okay. All right. So once you have the machine or when you decide what you're getting, you will have to select the post processor from the list in here. Now, for the purpose of our demonstration today, we'll just go with the standard post. We can select maybe a Fennec controller, a standard G-code output. You can select the file extension, NC. The next step you want to do is define your stock material. Select stock, box stock, and this will automatically take a look at the part that you designed, and it gives you the minimum dimensions that you need to machine this part. It gives you the length, width, and the height, which is the thickness. And you can enter in the dimensions that you have for the stock. For example, I could say my stock is going to be 500 millimeters by 400 millimeters and maybe 50 millimeters thick.
46 will be fine.
46. Okay.
46.
Okay. So I'll define the stock. So now you'll notice that the stock has been created, and it is 46 millimeter high. And since I put in 500 by 400, you can see the stock is larger. The next step is we want to align the stock to the part. Pick align. I'm going to have the bottom of the stock flushed with the bottom of the part because your bottom of the part is flat, and then the top has curved surfaces or sculpted surfaces. So we align it. Okay?
Yes.
So now the stock is positioned in the center of the part. In the next step, you can specify the origin. Where wouldn't you want to put the origin? So you can pick align. After you do the align, you click on set world coordinates. You choose where you want to put the 0, 0, 0. I'm going to put it to the stock. I could put it to the top face, so that would be highest Z, which would be the top face, and then you can choose the location. You can put it over to the west, which is in the center line of this part, or you can put it to one of the corners if you like. You can put it to the southwest corner. So depending on where you want to put the XYZ 0. Okay?
Mm-hmm.
And then you click OK. This will automatically transform your part and the stock, and it'll put it at the origin that you have in Rhino. Okay? So that's the location of your XYZ origin right in here. Okay? Any questions, sir?
It's okay. Until now, I have a little experience with Rhino Cam, but I don't know next step from there.
Okay. So the next step is you pick the material. In this case, I'll pick wood, or you can select the material from the list. You can also customize this to add your material types. Selecting a material also applies a texture of the material, so you can apply it to this texture in the simulation as well. Next step is we want to go ahead and define some tools. I have a library of tools loaded in here, or you can build your own tools of type ball mill, flat mill, corner radius, tools for engraving, chamfer, taper. You have all these tool types you can create. You can save them to a library as well. And then you want to go ahead and select a type of operation. So you want to first do a roughing and a finishing. Now, since this part has these curved top, right? It's not a flat top, it's a curved top. Yeah. I would do a 3-axis operation. So we'll go with 3-axis, and I'm going to select roughing. Now, in the standard configuration, you have horizontal roughing, parallel finishing, horizontal finishing, radial, and spiral. With the professional configuration, you'll have access to all of these methods. The first step is to do a roughing. You pick a tool. I could say I want to use a 12 millimeter tool or a 20 millimeter tool. You can select the tool type.
I have 6 millimeter or 8.
Yeah, 6 millimeter, or you can change it 8 millimeter. You can add new tools in here. You can call this, instead of 6.35, you can make it 6 millimeter. You can change the tool parameters in here. So we'll change it to 6 millimeter. We'll say save edit to tool. We can also add a new tool for 8 millimeter as well. Okay, so that's how you define a new tool. You can save up new tools in here. So for this particular part, we'll use the 8 millimeter tool. You then set your feed speeds. You enter in your cutting conditions, like you can specify the cutting parameters in here for your roughing operations. You can specify the step overs. You can control your cut directions. You have the step down for cut levels, how much of material you want to take down per pass. You can specify these in here. You can control the entry and exit parameters, and also you can specify fitting parameters for arcs, and then you pick generate. So in this process, it'll automatically generate a 3-axis roughing toolpath by taking into account the part that you modeled and the stock that you defined. So in this case, you can see it's roughing out everything that's can be removed. That's the stock. You can see it's cutting all of these areas out, right? But we don't want to cut
And
these areas.
how much time will take to this operation?
It depends on the feeds and speeds in here. So if you right click and go to information, it'll look at the feeds and speeds. So I'm only cutting at 600 millimeters per minute. It's going to take a long time. And also, we would not want to cut all of these into chips. We want to hold the part. So we want to put a boundary to limit the toolpath to a certain area. So we can actually go ahead and select a boundary in here around the part, right? So we don't want to cut the entire area. So what we can do is say we can put a boundary, like an outline around the part. So I'm just going to make a new layer in Rhino, and I'm going to use a command called curve in a Boolean, and I can just basically select everything in here, and I just click outside. You can see it creates a curved outline around the part, and I can maybe offset that out a little bit by maybe 1 millimeter, for example, or 2 millimeters. Right? I'm going to create a boundary and offset it out right there. So now for the roughing operation, I'm going to go ahead and pick this boundary in here, so the tool path will stay contained to that area only, and you can see it's not cutting all the way around, right? It's not cutting the outside. So you can create boundaries in here to contain your tool paths. And now if you look at the time, go to information, you see it's just a little over an hour for the areas that it's cutting. Now we'll go ahead and run a simulation in here. We can apply colors during simulation. So there's your roughing path. And I can always run the simulation faster by doing a pause and simulate to end. So there's the roughing operation.
I tried this method in Rhino Cam 2018 2018. Can you hear me?
Yes, I can hear you.
But the settings are different versus this version. It's not working in this same way.
Yeah, I'm not sure how you programmed it, but as you can tell here, I'm just programming it live on this demonstration, and you can see that we were able to create a roughing path. You would then want to go ahead and do a finishing operation. You could do 3-axis. You could start with a parallel finishing. And if you only want to do the top faces in here, you could just do the top faces. You can pick a boundary around the part to select the top faces, or you could do the entire thing by just selecting this boundary in here. I can pick the same boundary, and then I can go from a flat mill to a ball mill tool. If you have a 6 millimeter or an 8 millimeter ball mill, we can use a 6 millimeter ball mill. So I'm going to pick a ball mill tool right here and select the 6 millimeter ball tool that we have. Specify the cutting conditions, the cutting parameters. You can control your step overs in here. Specify how fine you want the cutter to step. And then you select generate, and that would create a 3-axis finishing toolpath. Now, if you want to avoid some of these areas from being machined, we can select a region to not cut into these areas in here. We can pick a region, so we can go back into the parallel finishing operation, and I can say select curve edge regions, and I can go ahead and select these areas to not to cut into. So I can pick those edges around the part right here.